So we're getting started on this GTV project, and what this customer is wanting to do is actually swap over to the earlier style step nose. These are a lot more rare and harder to find, and so that's why we're going to go through this whole process of swapping this all over. If the customer was to piece this together, it's actually quite spendy to get all your sheet metal, and so we were actually lucky in the fact that we were able to locate an entire front clip for the customer. So follow along and let's have some fun.
Now what we got going on here is the rear section of the GT. As you can see, we've got the hinges here. This is a very critical piece, especially on a GT where somebody has had a lot of homemade experience here. As you can see, the lines from this rear shelf here is just all over the place. We don't know if the windshield's gonna fit, if the rear glass is gonna fit. We know that when we sandblasted this car, there was about 1 inch of Bondo on this entire thing. So it got to the point where the sandblaster didn't want to do business with us if we were going to continue to bring them cars that were this bad, because it clogs up their paint booth, the EPA comes after them, it's really expensive, so it's not very good for business for them, nor for us. So what we got going on here is Ariel has spent quite a bit of time, as you can see, carefully popping all of the plug welds, the resistance welds, excuse me, off of this section so that he's able to remove this piece off of here. Now here is a good example of the inner structure and the outer structure of the sheet metal, how it all sandwiches together. See the fitment here. Now what are we looking at here? This is really important. This is something Darren pointed out. The sheet metal on the car, you can see the distance, the vast distance between this piece that is actually correct and this piece that is not correct. That's huge. So what we're gonna do is we've got this piece up into place. We're gonna mark off where this piece goes. We'll pull the piece off and then we're gonna assess what we're gonna cut off of here. Obviously a lot of this has to come out. We don't know if we're going to go down into the lower quarters section. We don't want to do that. We want to keep it right at the body line, because this body line is actually going to give us strength so that the panel doesn't warp as bad. As we all know, this is really thin metal. It's very weak, so we have to be really, really careful with it. As you can see, somebody did, I don't know, really tough repair. You can tell that they did this at home. I mean, the metal's nowhere near being close. Now, we also know that the deck lids on these things sometimes don't fit if it's not a numbers matching car. So we don't know what this is going to look like. We don't know what this is going to look like. And obviously, all of this has been repaired. So what we're going to do is we're going to, again, remove the sheet metal off of here, and then we're going to try to repair, again, we're going to try to repair the inside metal here. We don't know if we can. We might have to use some of the pieces off the donor car, but that's where we're at with this. I mean, when you get a GT, you have to be very, very careful. Any vintage cars, you have to be very careful of what the metal looks like, because you're going to come across this type of situation. And with expensive cars where it's hard to get parts, or the parts are really expensive, and then when you try to fit them, they don't fit. I mean, you can get into a can of worms really, really quickly. So this is something that we have to constantly educate our customers, especially new customers coming in, not understanding the labor that it takes to do stuff like this. Alright, so today we're talking about a Moto Guzzi Cafe racer that we're building. This motorcycle actually belongs to Darren. In 2012, winter 2012, I built a motorcycle, which is sitting right next to me, the motorcycle. Just a custom that I built, just for the fun of it. So, after building that motorcycle, Darren had an idea. let's build a badass cafe racer for the shop. That's what we're gonna do. So what he's got me going, this is the factory Moto Guzzi gas tank. So what I did is I took a plasma cutter and cut a line all the way down in the exact same position on both sides. Now you can see this other black line that I drew with the Sharpie, that's 3/4 of an inch on both sides. Now what we're gonna do, the gas tank used to sit like so. What Darren wants is he wants the top edge of this gas tank to kind of look like a triangle. He wants a more cafe racer style looking motorcycle tank, and this Moto Guzzi tank is just a little bit too wide for him. So he thought, hey, let's just cut this down, recess this in, and re-TIG weld it up, and it's gonna look nice. So that's exactly what we did. As you can see, that totally changes the dimensions of the gas. We're just slipping both sides underneath the top of the gas tank. By doing so, we had an excess of metal up here. So what I did is I just cut it out, and we're gonna sandwich it down like so. I'll trim the excess metal here, and we'll TIG weld all of this up. Now it's going to be a challenge TIG welding this up, obviously because of all the paint and fuel inside, so we're going to have to do a really good job to make sure that our welds stay really clean. This is going to look really good, and as you can see, it changes the styling of the tank, right? You can see how it's like a triangle. So it's going to look really good on this motorcycle. It especially looks good from the rear. You can see that. Looks pretty sexy, pretty race style. And up here in the front, even more so. So this is a motorcycle build we're going to be building on YouTube. Something that Darren's going to ride a lot. As you can see, we've got the motor mocked up into place. And as you can see, Darren's got the motor all torn apart. I mean, we're going through this entire thing. Darren has already shortened the frame. The frame used to be about right back here. He's removed a bunch of tabs off of this frame. We're gonna lighten it up, make it look really sporty, really sexy, and then we'll probably do this wild stainless exhaust and get that all TIG welded up. It's gonna be a pretty cool build. It's the first cafe racer that I build. I've built plenty of choppers, so I'm pretty excited about this build. It's gonna be pretty cool.
Okay, so this is my GT, and I'm always experimenting with different concepts on stuff, and I use this car for test mill most of the time when I do that. Now what you're seeing is the MSD system that is, what is trick about the MSD system is some of it is really high firing capacitive discharge system versus an inductive discharge system. This is where you get maximum explosion on the motor. And I'm going to show you a few things about this, and if you think about it, you can actually do a little hunting around. You can put together a really impressive capacitive discharge system for really reasonable money, especially if you're willing to use used parts. But there's a few things you need to know, okay? One, I wouldn't necessarily say you need to run like an MSD 7 series. The 6 series is the one that everybody knows, and it's really easy to come by, and you can find those on eBay fairly cheap. If you think about buying a 7 series, you need to know that it needs to be set up for a 4-cylinder motor, which means that you need to If you buy one used, for example, you need to send it to the factory and they'll set it up for 4-cylinder operation. That costs you about 35 bucks plus shipping. Or you can run the 6 Series system and you don't have to really worry about all this stuff. But here's what I want to talk about. If you elect to use a system like this, yeah, it tends to have a rather modern, complicated look to it, but it's not that complicated a system. What we have here is we have the MSD distributor, we have the HVC2 coil. If you're using this type of system that's on a car that is meant for the street, you need to be careful what coil you use. You can't just use any coil because this is such a powerful system that it's not meant for daily street use. But if you use the HVC2 series coil, you can run it all day, you won't have any problems. The other thing that's really cool about this setup is I have a timing controller on this, which means that my distributor is completely fixed. There's no centrifugal clutching in there that I need to worry about with trick springs and stuff like that. It's in a lockdown mode because everything's ran through this timing computer. What's cool about this is I completely control all phases of my timing to maximize my motor's potential. And we know that ignition systems don't increase horsepower, but they do most certainly maximize the horsepower that you have, especially when they're mapped out correctly. This is a fairly straightforward system. It's really easy to use, and I'm going to show you how you can make this work on an Alfa. The only part of this whole component system that becomes a little dicey is the distributor, because it's not meant for an Alfa. So I'm going to show you how you can cut your budget down by buying a knockoff version of that. And I'm also going to show you what model to use. Right now, when I show you the distributor that we're going to use on another car, it's actually a knockoff distributor that works very well with this system. And it's meant for a Volkswagen air-cooled motor. It takes very little modifying to make that work for you. Okay, so what you're looking at right here is, well, we're just going to call it a budget build. This is the MSD 7AL series set up for a 4-cylinder already with a multi-step retard system. Okay, that paired up with this, and I have a fantastic system. The only thing that's omitted from this program is the coil. Admittedly, there's 2 variations of the coil that you would have to use, and neither one of them are cheap, but it's well worth it when it's all said and done. This is where we're at. For example, here is your standard late 70s series Morelli-Plex distributor. Here is the MSD, or the knockoff MSD, set up for a Volkswagen Beetle. This is the clamping system, which ironically works very well for you. Here are the 2 systems. You can see that they both have a keyway. All right. The only difference is the Volkswagen keyway is slightly thicker than the Alfa keyway. So you only have to mill off the back side of this a little bit, and effectively this is ready to go. The one other thing that has to happen is the depth setting of this. When you use this knockoff, which is called a Pro Comp, when you use the Pro Comp version, this will cost you brand new, ready to go, about 95 bucks if you look around on the internet. Brand new, 95 bucks. That's really cheap. Anyway, so here is the clamping system for it. So basically what we're going to do is the inner ring we're going to throw away. We flip this over and we're going to set that back on there. The only other thing I need to do is I'll put this on the lathe and we're going to mill down just a little bit of the base. That way this slides down slightly deeper and it gives us plenty of room for the keyway to reach the oil pump drive on our motor. But effectively that's about it. You can have a complete MSD capacitive discharge system. Now this costs you brand new about 95 bucks. You can find this typically used, especially if it's coming from a 4-cylinder race series guy that backs his product up. If he says that he used this and it was working fine and he's got good rating, you could buy this for about 250 bucks. So you figure this, about 100 bucks, brand new. You can buy one of these systems off him for about 250, ready to go. Now you got one really trick system. The only thing you have to add to the formula from there is one of only 2 available street durable coils. Okay, you can either run the HFC or the HVC like we have in there, or there's one other one. Do your homework on that. It's real simple to figure it out. But all in all, for effectively less than 400 bucks, or about 400 bucks I should say, you can have a complete capacitive discharge system in your Alfa. What does that mean to you? It means that you're going to have a motor that's very, very responsive, very fast on the revving. other than the centrifugal weight of the motor. But it's very responsive. The other thing you get is you almost never going to have a car that wants to have valve plugs. Okay, so there's lots of benefits of running a capacitive system versus an inductive system. Inductive system, just about every one of you running something like that now. Even the high-tech versions are still inductive systems. The capacitive system, there's only a couple of manufacturers out there who develop this kind of stuff. One of them is Electromotive, fantastic system, but it is not cheap. It's not even close to cheap. It's really expensive stuff. And the MSD stuff is not cheap either, and especially if you bought it all new, because this will set you about $600 brand new. The 6AL, which is what I really recommend you use, is a whole lot cheaper than this. Anyway, the point is, with a Volkswagen air-cooled distributor, and with the rest of the MSD series, especially with a multi-step or a programmable timing module, you can really, really fine-tune and maximize the potential in your motor. Okay, so this is kind of a winding down on the setting up of a much more advanced ignition system on your car. By taking one of these aftermarket MSD style distributors meant for a Volkswagen air-cooled motor, the keyway, as we said before, is fairly close to that of an Alfa, but it's a little thicker on the backside, but the offset's the same. So what you do is, I have my ever so lovely busted oil pump, brand new oil pump, blew up on the dyno. Anyway, here's the keyway for an Alfa oil pump. You would file the back side of this, not the front side. File the back side of this down enough to where this fits. What is critical in that data though is make sure that it is a snug fit. Not a very tight fit, but just reasonably snug fit so you don't have a lot of slop in this. That way, as your distributor is hitting on throttle, it doesn't come out of phase with the ignition system, okay? It's not that complicated. This is kind of a fun little project if it's something you want to tackle. But anyway, so you file it down to where it fits the keyway just fine. And now you have the unlimited possibilities. You have an MSD type distributor you can install in your Alfa. You can choose your style of MSD ignition systems. More importantly, you have the access to something like this now. An MSD fully multi-retard setup on the ignition. These little knobs down here, I can dial in my ignition's firing throughout its complete progression. So at idle, I can have it at a certain adjustment, mid-range and top end. I can fully control the ignition timing on my motor and get the maximum potential released from my motor, which you really can't do with your standard ignition system. And again, there's a big difference between a capacitive discharge style ignition system and your normal inductive system, which is in your car. Your normal inductive system basically fires off about 7-8 volts going to the coil. The coil amps it up and throws it into the ignition or into the spark plug. With the capacitive style setup, it spools up the power into the actual coil and it has a saturation burn on the spark plug, which gives you a more complete burn and much better throttle response. This is a big deal. This is something, if you're just wanting to explore the potential of your motor, this isn't a bad way to go. It can get expensive if you buy all this stuff new. So if you're just experimenting, I would encourage you to explore your idea of buying some of this stuff off of eBay from a used setup and just see what you can do with it. You'll be amazed how much power you can release in your motor that you probably don't have access right now to. Okay, so this quick little segment is actually not on this car or anything like that. This is on the use of certain primers. In this particular case, this is called a surfacer. What a surfacer is basically, consider it kind of like a body leveling agent. When a car's been on the road for 40, 50, 60 years, whatever they have been, the metal tends to fatigue over time. It expands and contracts and starts to get little waves into it, okay? And those things become quite apparent once you start to put glossy finishes on, okay? Now, in this particular case, this car, it's been with us for a while. This had a quarter panel. It was literally just laid on top of another quarter panel. It was a real shabby repair. The style lines didn't match up to the door. The whole thing was in real bad shape, so everything over here had been reconstructed. the rockers, both sides replaced. So that meant the lower sections of the wings had been replaced. The front clip, the entire lower section of that front clip has been replaced. We changed out the bumper brackets, and we changed out the lower section of the headlight areas because all that had been destroyed, either rusted through or damaged from collision work and what have you. The thing of it is now we're at this point where this is, in this case, where this conversation may come in value to you. So let's say you are somebody who wants to try to do this in your own garage, and that's all fine and well. If you're going to use a surfacer, you're using it essentially as something you're going to remove almost all of it out of it. Okay, when you go to cut this stuff, you're gonna sand most of it off. You don't want surfacer to be. You don't want a lot of it still existing on the car when the car is heading into paint, because basically, if you looked at it as a very liquidy form of body filler. And what happens is over time it will extract the pigments out of the paint, and it will literally make the paint somewhat blotchy, or it won't retain its luster. Okay, so surfacers are not something we want an abundance of, but right now this car's got an awful lot of it on there. Okay, with that said, I would gather to say probably close to 90% of it's gonna get sanded right off. Okay, because we're using it to level the deficiencies in the body. That means we also put an excessive amount of it on the style lines. We're doing that because we want to shave the style lines and make them absolutely sharp as can be, just like they were when the car was brand new. We're not using this as a cheater way of doing the body work. We're using this to basically shape the lines that are already there, but making them very crisp, because when paint goes on this thing, those lines will become very relevant. So you need to make them sharp now. This car has been through a lot to get to this point. Now we have surfacer on it. We're gonna let it set for a very long time, let the stuff completely shrink down, let it thoroughly dry, and then we're gonna knock it down. And then the car will be ready for sealer and color. It's kind of cool to get to this point. It's taken a lot to get here.
Sean's been doing a good job putting this car back together, and he's gonna bring you through his process on replacing these things. Sean?
So we've got a piece here that has already been prepped. We've already folded this edge over right here, and we've also made our holes for our plug welds along here. So this guy actually fits up real nice and tightly in there. Initially, when these pieces come, they're gonna look about like this. So when you mock these up, you have to figure out where you want to trim them at and put your line across there, and then you can trim these guys down. Once you have that accomplished, then you can figure out where you want to cut your quarter panel, and then you can go ahead and stick your piece up, make your line across there, and now you know where you're going to hit it. So as you can see, once you know where your line's at, we've actually come back and flanged this. We've cut out the corners, and we're going to butt weld this along these corners. And then along this inside, we actually had to fabricate another piece to continue this frame that comes down that skin wraps around. So up here in the front, it's actually a little bit more difficult to do because you got several things going on here, and there's not much structure going on behind this fender. So I haven't actually cut this out yet, but you can see where it's been flanged. We've flanged it as far as it can go, and it does great going along a straight line, but once you start getting to these curvatures, you're gonna have to actually notch this out and then just butt weld this up in here. And we're gonna do this on both corners of this. Behind here, there's also going to be a inner fender apron that we're going to have to fabricate and bring that down. And what that does is keeps a little bit of structure going in this and keeps this line going all the way down for us.
Now, the reason why Sean was talking about how these are pretty simple to do, except they're labor intensive, is because of little things like this. We have to make sure that the contours of this fender are going to go in line with the contours of this rocker. Now you can see as soon as I press this in, this entire lower fender moves. So that's critical, that we got to make sure that this angle is going to be matching the door, as well as a quarter angle down here is going to be matching the contour of the door. Now, before we do that, we have to fabricate this little intersection piece. We had to do the same thing on the back side, but the reason why this is more difficult, takes more time, is because we have to unbolt this door multiple times. We have to unbolt it, pull it off, and bolt it back on after that piece is fabricated to make sure that the door gap is going to be consistent with the lower fender replacement piece. So that takes time. We have to pull the door off, pull it back on, realign it, make sure that all the contours are matching and steady while this little inner fender section is mocked up, and then we will mock this back up and make sure that all the angles are consistent. Now that takes quite a few times. Sometimes it'll take us 3 to 6 times unbolting and bolting this door, to make sure that this, again, all of this is going to be consistent, all these angles, all these contours. So it's a little bit easier to do the back because you don't have to unbolt the door, you can just open the door. But obviously we need the space, we need the room to work back here and do some welding. Alright, so we're doing a video update on the reconstruction of this GTV. Now, we're working our way around the metal. We're up to the front nose, and what's going on here, as you can see, is Sean has everything mocked up and clamped down. He has the hood bolted up into place. The reason why you want to do that is because before you commit anything to the front end, this is a replacement hinge panel. They're really hard to come by. So we've got this hinge panel that needs to get welded up into place first. We've got the hood mocked up, bolted onto that hinge panel, and it's up to the hood's alignment to dictate where this hinge panel needs to get welded. That's really important because obviously it was in a front end collision, things are tweaked and twisted. If we were to weld this piece in and then try to fit the hood, we would be in a world of trouble. So after the car gets nice and painted, the bodywork's done, it's cut and polished, and we're going to deliver the car, and we're putting the car back together, we're going to know that this hood and all the gaps around it are going to fit really nicely because we're mocking it up right now, and then we're going to weld it.